Before we get to gradient descent though, we need to figure out what the quality metric we're trying to optimize is. And that quality metric is going to call the data likelihood. So let's dive in and explore exactly that concept. To better understand the data likelihood, let's start with some simple examples and try to understand what W is trying to do, what we're trying to do here in the learning problem. So let's say that we have this data point that has 2 awesomes and 1 awful. So let's call that input x1, and we're going to try to output y1, which is that this is a positive sentiment. This is a review of positive sentiment. If our classifier were really good, if W's were good, what would happen? Well, for this particular input, it would output y hat for 1 is also equal to +1. In other words, y hat agrees with the true label y. So what should we do for y hat to agree with the true label y? We're using logistic regression. Well, we're going to try to find a W that makes the probability that y is equal to +1 when the input is x1 and the parameters are W. We want to make that as big as possible. In other words, we want to make the probability that y is equal to +1 when x1, number of awesomes, is 2, and x2, number of awfuls, is 1 for the parameter W. We want to make that probability as big as possible. But that was for a positive example. We want to make the probability that y equals +1 as big as possible. Now let's take another example. Let's call this example x2, where it has 0 awesomes and 2 awfuls. It must be an awful review, an awful restaurant. And so the sentiment for y2 is -1. So if our classifier is good, if W is good, in this case we should predict that y hat 2 is equal to -1 to agree with the true label. So in this case we're not maximizing the probability that y equals 1, but we're maximizing the probability that y is equal to -1 when the input is x2 for the parameters W. In other words, when the input is x1, we're going to maximize the probability that y equals +1, and when the input is x2, we're going to maximize the probability that y is equal to -1. That's what the data likelihood tries to do. But let's dig in and understand that a little bit better. Now, we just don't have 2 training examples, we have a ton of examples. We have a big data set. So what we're trying to do? So let's look at the first example. In the first example, we want to maximize, since it's a positive example, we want to maximize the probability that y is equal to +1 when the input is x1 and the parameters are W. So in this case is the probability that y is equal to +1 when the number of awesomes is 2 and the number of awfuls is 1 and the parameters W. So we're trying to make the probability y equals +1 given x1 to be as big as possible. For the next example, we're trying to make the probability that y is equal to -1 given x2W to be as big as possible. It's a negative example. For the third one, it's also a negative example. So we're trying to make the probability that y is equal to -1 given x3 and W. For the fourth one, we're trying to make the probability that y, it's a positive example, so y equals +1 given x4 and W as large as possible. So in other words, for the positive examples, we're trying to make the probability that y equals +1 as big as possible. For the negative examples, we're trying to make the probability that y is equal to -1 as big as possible, which is pretty natural. And we want to do that for each example, for every single one of those. Now the question is, how do we combine? Like if we have a single quality metric, how do we combine these? And you can imagine multiple ways of combining this. Averages, I don't know, all sorts of ideas out there. The way that you typically combine when you're doing what's called maximum likelihood estimation or maximizing likelihood is by multiplying these things together. So you multiply. So in other words, you say that it's the product of y is equal to +1 given, that's from the first line, given x1 and W, times the probability that y is equal to -1 from the second line here, given x2 and W. And the third line is also negative, so times the probability that y is equal to -1 given x3 and w, and so on. So you just multiply them all together. Here's a side little note for those who know about probabilities. The reason you multiply is that you assume that every row is independent of each other, so there's an independence that comes into play. But don't worry too much about this. Just think about as a multiplication. Okay, so let's do that a little bit more explicitly. Now we have these data points 1 through 4, and for each one of them, we're trying to maximize the specific probability. So for the positive examples, we're trying to maximize the probability that y equals +1. For the negative examples, the probability that y equals -1, given the parameter w's, and we find w that makes those as big as possible. So the likelihood function, the thing we're trying to optimize is the product of each one of these probabilities. You like that animation? Pretty cool, huh? So we're going to use a shorthand notation here. So for the first example, we have that y1 up here was +1. So we're going to denote that by probability of y1 given x1 and w. So the y1 is going to get from this +1, and x1 is going to come from this representation of x. And similarly for the other ones. So so that the notation doesn't get long and heavy, we just say probability of y1 given x1 and w, probability of y2 given x2 and w, probability of y3 given x3 and w. And we're just multiplying them together. And finally, so that that line doesn't get really long, because if we have a million training examples, there'll be a million of these entries, we use the product notation. So this is the little notation over here, and it just says, I'm going to just write the same function here, L of w is going to be equal to the product that ranges from the first data point to n, which is number of data points, of the probability of whatever label yi has, +1 or -1, given the input xi, which is the sentence of that review, and the parameter w's. This is the likelihood function that we're trying to optimize. So our goal here is to pick w to make this crazy thing, this function, as large as possible. That's our goal.